Azure Data Factory self-hosted integration runtime. In this course, we will start from beginners topics and cover intermediate and advanced topics. This is a single course you need if you are planning to use self-hosted integration runtime or if you are already using it. Once you finish this course, you will be able to configure self-hosted integration runtime, security best practices, how to use integration runtime with organizational standards, and monitoring and troubleshooting steps. The prerequisite for this course, you should have a basic understanding of Azure Data Factory. We have categorized this course in 3 parts: beginners, intermediate, and advanced. In beginner, we will try to cover fundamentals of self-hosted integration runtime and get to know the concepts. In intermediate, our main focus will be on multiple configuration options available. Under advanced, we will work on diagnostic tools and monitoring of self-hosted integration runtime and sending the logs to Azure Log Analytics Worspace. Each section of this course contains demo, and in the last we will have one bonus topic, which is containerization of self-hosted IR. So let's start our course from the question, what is integration runtime? The integration runtime is the compute infrastructure that is Azure Factory pipelines uses to provide data integration capabilities across different network environment. So it is nothing else but a compute infrastructure. Type of integration runtime. There are 3 types of integration runtime: Azure integration runtime, self-hosted integration runtime, and Azure SSIS integration runtime. Azure IR is also called as default integration runtime, and the compute infra is provided by Azure. In self-hosted IR, the compute infra is provided by us and we have to maintain it and secure it. So what does it mean that Azure providing compute infra? It means Azure has already deployed many containers in their data centers. And when they run our pipeline, one container is allocated to our pipeline to run the required activity. What is self-hosted integration runtime? A self-hosted IR can run copy activities between cloud store and data store in private network. It also can dispatch transform activities against compute resources in an on-premises network or Azure Virtual Network. The installation of self-hosted integration runtime needs an on-premises machine or a virtual machine inside your private network. Command flow and data flow is something which is very important to understand when using self-hosted integration runtime. Let me try to explain it as per steps involved in the process. So we have 2 networks, one is Azure, another one is the local private network. The first step, a data developer first create a self-hosted integration runtime within an Azure Data Factory by using a Azure portal or PowerShell commandlet. Then the data developer create a linked service for an on-premises data store and specifying the self-hosted integration runtime instance that the self-service should use to connect to the data store. The second step is the self-hosted integration runtime node encrypts the credentials by using Windows Data Protection Application Programming Interface, also called DPAPI, Windows Data Protection Application Programming Interface, and saves the credential locally. If multiple nodes are set for high availability, the credentials are further synchronized across other nodes. Each node encrypts the credentials by using DPAPI and store them locally. Credential synchronization is a transparent to data developer and is handled by self-hosted IR. Third step, Azure Data Factory pipeline communicate with self-hosted IR to schedule and manage jobs. Communication is via control channel that uses shared Azure relay connection. When an activity job needs to be run, the service queues the request along with any credential information. It does so in case of credentials aren't available stored in self-hosted integration runtime. The self-hosted integration runtime starts the job after it polls the queue. And the last step is the self-hosted integration runtime copies data between an on-premises data store and cloud storage. The direction of the copy depends on how the copy activity is configured in data pipeline. For this step, the self-hosted integration runtime directly communicates with cloud-based storage service like Azure Blob Storage over the secure HTTPS channel and in on-premises like MS SQL. Let's do a demo on creation of self-hosted integration runtime and try to see how we can use it in our data pipeline. So let's start our first demo. In this demo, I have already provisioned a data factory and a storage account, and I have installed SQL Server on my local machine, and I have created a table named hero, and I have inserted some data here. Now my task is how can I connect to my local SQL Server from Azure Data Factory, and for that I need to create an integration runtime and install it on my local machine. So first let's go here on Data Factory portal in the tools, and then we will try to create a new integration runtime. And the new integration time, we have three options. This one is preview, we don't have to worry about that one. So we have two options for that to create our integration runtime. I'm going to create this self-hosted one, and I am choosing my own machine. And let's give it a reasonable name. So I am putting it as on-premises hyphen integration runtime. Create. So this integration runtime has been created successfully. Now what I have to do, that I have to download the integration runtime software and install it on my local machine, and then I will use these keys to register this data factory to that integration runtime. So let's download it quickly. It's downloaded. Let me try to install. I will not change anything. I will keep it in my default folders. Okay, so the installation of integration runtime software is finished. Let's try to register. So over here you see register integration runtime. Welcome to Microsoft Integration Runtime Configuration Manager. Before you start, register your integration runtime node using a valid authentication key. So this valid authentication key we already seen here in our data factory. So this is the key. I will just copy it and go to my integration runtime manager and paste it here. And you see it's a valid key. I'm not going through all other details right now because it's a basic demo right now, and we will see other settings later. it is trying to initialize this process. In the meantime, let's go here and see there is no host available. So there is no node registered right now on this on-premises integration runtime, and you can see here in the nodes there is no information, and once that registration is completed we can see that node over here. So let's go back. So this registration has been successful. Let's launch our configuration manager, and you can see SelfHosted is connected to the Azure cloud service, and we can see the message here as well, connected to the cloud service. Let me try to refresh it. It is refreshed, and now you can see it is running. Let's go to on-premises IR and let's go to the nodes, and you can see we have seen our node here, which is my local desktop. Okay, so let's try to create a pipeline which will connect to our on-premises SQL Server and try to move the data. I will try to move this data from my local laptop, from my local SQL Server to storage account as a CSV file. So let's do that. I'm putting the name of this pipeline, move data from SQL to blob. Then let's mention here copy data. We will not change anything here. We have to define the source. So we need to create a source here. So let's create which source is this. I am saying SQL. So I'm taking SQL Server, which is on-premises SQL Server, and then I'm going to create a link service. So this is, I'm keeping at default SQL Server 1, or I can say on-prem SQL Server. And it is asking which integration I am trying to use. So right now it is default one. I don't want to use default. I want to use my on-premises. Then server name. So I have to copy the server name from here. This one. And it is database name is db01. I am using SQL authentication, and my user is SQL admin. Let me put it password. We can use Key Vault for this, but right now it's simple demo for copying data from on-premises to Azure cloud. So that's why I'm keeping it simple. Okay, and now let me try to test this. So connection successful. That means I am able to connect to my SQL Server, which is installed on my on-premises environment from my data factory. Let me hit create. And now it's asking me the table, and you can populate all the tables which are there in your database. I said okay. So now our source is ready, and if you click on this preview data, you can see the data as well, which is there in my on-premises database. Now source is defined, we have to define the sink. So we have to click on new, and now I am choosing storage account, which is a blob storage account. I am going to create a CSV file, so I'm choosing this file format and I'm putting it as SQL data, and I have to create a new link service for my blob. I am choosing my auto resolve integration runtime. I don't want to choose my on-premises one, but if your blob storage account is using private endpoint, then you have to use this on-premises IR. And why you have to use on-premises IR? Because when you have a private endpoint enabled and you disable the public endpoint on your blob storage, then you can access your blob storage only from the private network. Then this auto resolve integration runtime is not going to help you, because it's going to connect using public IP, which is disabled on the storage account, and then you have to select your self-hosted integration runtime. And then from self-hosted integration runtime, you can connect to Azure Blob, because your traffic is traveling in the private network. But right now my blob is having public endpoint enabled, so I am just using the default integration runtime and then select the storage account. If I want, I can do my test connection. See, it's successful. Let me create it. Let me try to create the sync. Hit new, and I'm going to search for blob storage account here. Let me hit continue, and which file format I am going to use. So I am going to use CSV file format, and then link service, which is Azure Blob Storage, which we have created previously, and I will just hit OK. Okay, so now it is created. Let me hit open and set this configurations. So in the connection, I will put the file path. So what is the container here? I am going to use, I already created this data container inside my storage account. So I will use it as a data. And for directory, I am going to use SQL data. And in this file name, I am going to use a dynamic file name, like which is going to be generated whenever we run our integration runtime. I mean the pipeline. So I have put it as this. So I can click here, I will show you. So I am going to concatenate this pipeline run id .txt in the last. Let me hit OK. I will not change anything else. And let me go in my pipeline here and let's validate. So pipeline is validated successfully. Let me try to trigger this. Okay, that's fine. Using last published configuration, that's fine, but I don't have any last published configuration. So for that I need to publish it. Okay, so it's published, and now let me try to hit trigger now. Okay, and we can see the pipeline. Right now it's in queue. It's successful, and you can see the run ID is C9F something. Let me go to the storage account and open this data container. You can see in the data container, I have this folder name SQL data, and inside this SQL data, we have this file. Let me open this file and click on edit. And over here you can see we have our on-premises data stored in the storage account, name and city and their respective values. So this is how we can use integration runtime to connect to the on-premises environment, SQL database or any other file system and move the data to the Azure cloud in the private network. So we have finished fundamentals of self-hosted integration runtime and also saw that how we can set up self-hosted IR and run data factory pipeline on self-hosted IR. Now let's start our second part of course, Azure Data Factory self-hosted IR. In this section, we will try to go deeper into the configuration options. So let's just jump into it. High availability and scalability. You can associate a self-hosted IR with multiple on-premises machines or virtual machines in Azure. These machines are called nodes. You can have up to 4 nodes with self-hosted integration runtime. The benefit of having multiple nodes on on-premises machines, it's high availability of self-hosted integration runtime so that it's no longer the single point of failure in your big data solution or cloud data integration. The availability helps ensure continuity when you use up to 4 nodes. Improved performance and throughput during data movement between on-premises and the cloud data stores. Scaling considerations. In the beginning, we cannot analyze all the possible future requirements and hence as soon as our requirements grow, we need to scale our self-hosted IR accordingly. For scaling, we have 2 options, scale out and scale up. Many of us already heard about these 2 terms. Let me explain it. So scale out means we will add more people, that is machines, to share the upcoming load. When processor usage is high and available memory is low on self-hosted IR, a new node to help scale out the load across machines. If activities fail because of the timeout or the self-hosted IR node is offline, it helps if you add a node to the gateway. Scale up, it means we need to make our machines more powerful and more stronger. And how we can do it? We can do it by adding more CPU and the RAM. When the processor and available RAM aren't well utilized, but the execution of the concurrent jobs reaches a node's limits, scale up by increasing the number of concurrent jobs that a node can run. You might also want to scale up when activities time out because of the self-hosted integration runtime is overloaded. Proxy server consideration in initial setup. If your corporate network environment uses a proxy server to access the internet, configure the self-hosted IR to use appropriate proxy settings. You can set the proxy during the initial registration phase. When configured, the self-hosted integration runtime use the proxy server to connect to the cloud services source and destination using HTTP or HTTPS protocol. This is why you select change link during the initial setup. There are 3 configuration options. Do not use proxy, use system proxy and use custom proxy. Do not use proxy means you are not using any proxy and connecting directly to the service. Use system proxy means you are going to upgrade the configuration files, which is diehost xcconfig and diewp xcconfig file of integration runtime, and then use that proxy while connecting to the cloud services. Use custom proxy. Here we will configure the HTTP proxy settings to use self-hosted integration runtime instead of using the configurations in the configuration file. Address and port values are required. Username and password values are optional. Depending on your proxy authentication setting, all settings are encrypted with Windows DPAPI on the self-hosted integration runtime and is stored locally on your machine. So if we already have set up our integration runtime, then how to set up proxy after the setup? So after you register the self-hosted integration runtime, and if you want to view or update the proxy setting, use Microsoft Integration Runtime Configuration Manager. Open it and go to the settings tab, go to the HTTP proxy and then click on the change button, and there you can set up your proxy configurations. One thing to note here, that if you set up a proxy server with anti-NLM authentication, the integration runtime host service runs under a domain account. If you later change the password of the domain account, remember to update the configuration settings for the service and restart the service. Firewall and proxy issues. If you see error messages like shown in the screen, the likely reason is improper configuration of firewall or proxy server. Such configuration prevents the self-hosted integration runtime from connecting to Data Factory pipeline to authenticate itself. Ports and firewall setting. There are two firewalls to consider: corporate firewall, Windows firewall. Corporate firewalls runs central router of the organization, and Windows firewall runs on daemon on your local machine. At corporate firewall level, you need to configure the mentioned domain and outbound ports. Like here, if you see, we have to open 443 port for the mentioned URLs, for Data Factory URL, for Azure Relay URL, and then have download center for Microsoft and Key Vault. So we have to open 443 port for these URLs. Then only our on-premises integration runtime can connect to these services. These URLs and the ports normally already open on your Windows firewall. If not, you have to open there as well. Based on your source and sinks, you might need to allow additional domains and outbound ports in your corporate firewall to be open. For example, as you see, for storage account and Azure SQL database, we need to open 443 for their respective URLs. Remember, it is not right to install both integration runtime and Power BI gateway in the same machine, because mainly integration runtime uses port 443, which is one of the main ports being used by Power BI gateway as well. Self-hosted integration runtime. If you want to share it with other data factory, then we have this option where we can grant permission to others data factory manage identity on our self-hosted integration runtime, and then they can create a linked service to our integration runtime to use into their pipeline. We will see this in our demo. Okay, so let's start our second demo. In this demo, we will see how the high availability will be maintained in self-hosted integration runtime. So in the previous demo, we already seen that we have this on-premises integration runtime I created. I click on this one, and if I go on the nodes, you can see I have only one integration runtime running on my local laptop. So if you have a multiple machines, then what you have to do, you just install the integration runtime and register it with the same key, and once you register it, you will see multiple nodes here, which is maximum 4 nodes you can use, and also you can use only Windows OS. You cannot use Linux or any other operating system, because integration runtime does not support any other operating system right now. It only supports Windows operating system. And when you have a multiple nodes registered here, then you have a high availability, and whenever you want to update your one node, I mean you want to update your integration runtime, currently it is the latest one, and if you want to update it automatically, then the update happen on one node first and remaining will be up and running. And once the update completed on one node, then this will take charge and it will start working on the activities of pipelines, and remaining nodes will start updating. So this is how you can add more nodes here and you can have high availability. Here you can see the limit concurrent jobs. So right now I have limit concurrent jobs is 14. That means I can run only 14 jobs at a time on my machine. This number is totally depend on your compute power of your machine. So it's having some kind of algorithm in the backend that it will check the target machine and check how many CPUs are there, and on the basis of those CPUs this limit can be increased and can be decreased. We can increase it, for example, if I want to increase it right now, so let me try to put it 100. I cannot put it 100 because my machine does not have that much CPU to resolve or to service 100 concurrent jobs. You can see the value must be at most 56. So this is Microsoft algorithm which is calculating that how many concurrent jobs is running my can run on my machine. So I can give 56 maximum concurrent jobs, not more than that. And if I increase the vCPU size on my machine, then I can increase this concurrent job also. One more thing, this concurrent jobs does not means that you these jobs will run on your machine and equal amount of resources will be allocated to each job. It's not like that. Whenever load will come, the job will be allocated, allocated out of the pool. Like for example, you have 16 vCPUs, so it will start from one, and if the activity goes further, then it will eat more CPU. There is no algorithm in Microsoft which will tell that equal amount of resources will be allocated for each job. It can be possible that your one job can eat all of your CPU, and there is another multiple jobs which are not even eating 1% of the CPU. So we have to keep it in mind that this thing needs to be in an area where you should not have so much concurrent jobs which will resolve in 100% CPU utilization. Then your pipelines will not able to perform well. Your activities will be slow down. Now next topic here is auto update. We have seen in demo, we can enable or disable the auto update. If you disable it, you have to do it manually by installing the latest software, and if you enable it, automatically the Azure will connect and it will try to update your integration runtime, and you can mention here the schedule of your upgrade, time zones, etc. Today we will also see the sharing of our self-hosted integration runtime. Sharing means that I have this self-hosted integration runtime for my DF SHIR GSWP data factory. Now I don't want to create another integration runtime for different data factory. I just want to use the same one, and it can be possible in scenarios in big organization where you can create a shared integration runtime, and other applications and other business can use the same integration runtime for their data factory. So you can grant permission by click on here, and then it will use your integration runtime to run their workload. And then links is like if somebody is creating or using your on-premises integration runtime, then they will create a link service for your integration time, and you can see those link service here. So now we have already talked about the scaling part, then high availability part, auto update part, sharing, and the links. Let's go to the proxy configuration on our machine and see what are the possible configuration options are available. So this is our machine where self-hosted integration runtime is installed. I will try to open the folder. Now let's open the C drive, and you can see in the program files we have our integration runtime installed. Now inside this integration time, for proxy configurations, we have two files, which is very important. We have two files to update the proxy configurations. So we will go here in 5.0, then shared, and then we have two files which is called diehost exe configuration file. You can see here's a configuration source, and another one is diewp exe configuration source. These two files needs to be updated if your organization is having some kind of proxy servers in the middle and you have to use those proxy servers. So let me open a notepad in administrator mode, because you cannot update these directly here. You cannot update it. And then I will open file, new file, file, open. I will go to C drive, program files, runtime, 5.0, shared, and then I will try to open the configuration files. For that I need to change it from text document to all files. And this is our first configuration file, diehost.exe configuration files. Let me open it, and in here you need to search for system.net. So let me go down a little bit, system.net. Here you can see this is system.net, and now in here you can see use default credentials only. Now we need to define the proxy settings here. How I can define my proxy settings? We need to remove this line which is default. I don't want to use default, and I want to use my own proxy. So in the default proxy I said it is enabled, and then I am saying that my proxy address is some proxy.domain.over and the port number, and bypass on local I am making it as true. And once you define this over here and then you save it, and then same thing you will do on the another file which is diewp exe file. Let me open it, and now here you search the same thing, system.net. I will just make a copy out of it so that it will not misconfigured, and I have to search system.net, which is here, and same proxy configuration settings I have to update here. So I just removed this default line and add my line default proxy enable true, and then my proxy server information here, and just save it. Now once you save this information, you have to stop and start your self-hosted integration runtime. So you see it's now start failing to connect the cloud service. Why it is failing? Because I have mentioned here that I am going to use this proxy server, which is, I just took an example and I don't have any proxy server right now, and that's why it's failing. Let me just revert my changes, save it, and I have to open another file which is diehost file. Let me copy this part and go to diehost file, . open, and I have to revert back my changes over here for system.net. So these changes I have to remove and paste only this one, save it, and now I have to restart my shared hosted integration runtime once again. Okay, so my self-hosted integration runtime is now connected to the cloud service when I'm using my default settings. Let's discuss about the organizational level of proxy settings. So if your company's network architecture involves the use of private endpoint, and for security reasons your company's policy does not allow a direct internet connection from your VM or on-premises machines to Azure Data Factory service URLs, then you will need to allow a bypass ADF service URL for full connectivity. And how you will use it, this bypass? You have to update these two files. One is the diehost.exe, another one is the diewp.exe. And what exactly you have to update it, let me tell you. We will update the same block, which is system.net, and here we have to remove this part. I just remove till this one and paste it here. So I am writing in system.net that I want to use a bypass list, which is my ADF name and the URL of my ADF, and then on which proxy I am mentioning my proxy server here. So I'm mentioning my proxy server here, but at the same time I'm also using my bypass list, which will bypass this URL to go through the proxy, and it will connect directly to my ADF. It can be possible that your organizational not only blocking the data factory URL, it will block some other URLs like storage account URLs, like key vault URLs. So if that is going to be happen, then you can add more bypass lists. So for example, if you want to add one more bypass list here, you just have to add a add address block here. For example, let me try to add this one here. So in here you see I'm adding a regex, which is allowing all kind of data factory URLs as a bypass list for my proxy server. So if I mention this settings, then all the ADF's URLs will be bypassed from my proxy server, and my integration runtime will directly connect to those data factories. It is very useful information. You have to keep it in mind whenever you are using a proxy server, that your destination URLs is allowed by your proxy to connect. If it is allowed, then totally fine, no problem. If it is not allowed, then you have to use this bypass list. Now we will see, let me try to close this. I don't want to save anything. And let's see how we can use the same integration runtime with other data factory. So let me go here. I have already created a data factory with df share gswp2. And here the important part is that I need to check the manage identity of it. It should be on, it should not be off. If it is off, you cannot use the sharing of integration runtime to different data factory. The manage identity should be on, either system used manage identity or user assigned manage identity. So I'm using the system assigned one. And for that I have to go here and give permission to my data factory on the existing integration runtime. So let me click here. I already showed you this sharing button, and here I have to grant permission. So I click here and I am going to use system assigned manage identity for data factory, not the user assigned. And I'm just searching my data factory. I have only one, so it was already there. Click add. It's added, and then apply. Now I have given permission to my data factory, which is GSWP2 on my integration runtime. Now I have to go on my data factory, which is GSWP2, and in here I will open my studio, go to manage, and then here you can see I have no linked service created, and in the integration runtime I have auto resolve integration runtime. So here I have to create a link service for my integration runtime, which is already present installed on different data factories. So let me create a link service here for SQL. I just keep it like that, and here I need to I want to use the another one integration runtime, which is the linked self-hosted integration runtime. Now I'm not going to create a self-hosted integration runtime, I'm going to create a linked to a existing self-hosted integration runtime. Continue. It's fine, I'm just keeping name like that, and here I have to put the resource ID of my integration runtime. So I have to go here, click on my integration runtime, and then sharing, and this is the resource ID of my integration runtime. So I just copy it and paste it here, and I'm going to use system assign manage identity for it, then create. It's showing error here, but here you can see in the notification pane that it is created successfully. I just do one thing, I just cancel everything and try to recreate SQL Server, which is the on-premises I want to use, and then here you can see it's green and integration runtime is ready. Now I have to mention my SQL Server name, so I have to copy it from here. And then database name is db01. SQL authentication, I am using SQL admin as a user, and password, and let me hit test connection. Okay, so this is connection successful, means that my data factory, which is GSWP2, using self-hosted integration runtime, which is installed on GSWP, is able to connect to my on-premises SQL Server, and the connection is successful. I'm not going to show you the same creation of the pipeline and move the data, because we already seen it in our demo 1. So this is how we can confirm that we can share the self-hosted integration runtime with different data factory by giving access to the managed identity of your data factory to the original, or I can say the integration runtime data factory here. And once you give it, and you can see in the links, if I cancel it and again open it and then go to the link, right now it's not showing, it should show. So here you can see the link has been created for data factory TF SHIR GSWP2 on my integration runtime. In the last module, we have learned about scaling, proxy settings, and port and firewall for self-hosted integration runtime. Let's start our third module, which is advanced, and we will see topics like diagnostic tools, monitoring, and centralization of the logs. Let's start from auto update option present in self-hosted integration runtime. We have an auto update option available. You do not have to update the software manually. You can check the version either in your self-hosted integration runtime over here, or you can see the same version into our portal as well. Generally, when you install a self-hosted integration runtime in your local machine or Azure VM, you have two options to manage the version of the self-hosted IR: auto update or manually update. ADF releases two new versions of self-hosted integration runtime every month, which includes new features, bugs, or enhancements to be fixed. We recommend users to update the latest version. The most convenient way to enable auto update when create or added self-hosted integration runtime is auto update, of course. The self-hosted integration runtime is automatically update to newer version. You can also schedule the update by most suitable time slot you wish. Note here that if you have multiple self-hosted integration runtime, there is no downtime during auto update. The auto update happens in one node first while others are working on the task. When the first node finishes the update, it will take over the remaining tasks when other nodes are updating. If you only have one self-hosted integration runtime, then it can cause some kind of downtime while it is updating automatically. Diagnostic tools for self-hosted integration runtime. The self-hosted integration runtime is the compute infra, and it is creating some kind of logs in the backend. The installation of self-hosted integration runtime needs an on-premises or virtual machines in a private network. Sometimes it's hard to investigate the issues in on-premises machines such as network, firewall, dependencies, or other OS related issues. This topic describes a new diagnostic tool to troubleshoot problems in on-premises environment. The tool runs a series of test scenarios on a self-hosted IR. Every scenarios have a typical health check cases for common issues. Customer can trigger the troubleshoot problems, feature it if they encounter any issue. The tool collects the customer environment information and execute the health check cases. The execution result and detailed log messages are generated as a HTML format. You can review the error and get the suggested mitigation methods or public document URLs from the report. Monitoring self-hosted IR. By default, the self-hosted IR diagnostics and performance telemetry is saved locally on the virtual or the physical machine that is hosting it. Two broad categories of telemetry monitoring the self-hosted IR is event logs and performance counter. When logged on locally to the self-hosted IR, specific events can be viewed using Event Viewer. The relevant events are captured in two event viewer journal named Connector Integration Runtime and Integration Runtime respectively. While it's possible to log on to the self-hosted integration runtime individually to view these events, it's also possible to stream these events to Log Analytics Workspace in Azure Monitor for ease of query and centralization processing. We will see this in our demo. When deployment requires a more in-depth level of analysis or has reached to a certain scale, it becomes impractical to log on to locally on self-hosted integration runtime hosts. Therefore, we recommend using Azure Monitor and Azure Log Analytics specifically to collect the data and enable a single pane of glass monitoring for your self-hosted IR. This will also be shown in your demo. Okay, so in this demo we will see how diagnostic tool works, also check the monitoring data locally present on the machine, and also cover configuration of centralized logging of IR to Azure Log Analytics Workspace. Okay, so let's start our third demo. In this demo, we will start from seeing the auto update option we have in our integration runtime. So I clicked on our integration runtime and you can see we have options like settings, nodes, auto update and others. I already discussed this auto update in my first demo. I just briefly introduce you that we have two options here for auto update. One is the disabling. That means we have to maintain the patching of our integration runtime by ourselves, and if we enable it, Azure will take care of it and it will update the integration runtime software on our machines. Important thing to note here that if we have multiple nodes here, then this auto update will update node one by one, so that our integration runtime will always ready for our incoming request to service. But if you have only one node over here, then it will be a short downtime for our incoming load, because when it is going to update, it will stop the service of integration runtime and then restart it. So this is all about the auto update. About the version, you can see the version of your current on-premises integration runtime here in the portal, and also you can see it on the integration runtime itself. So if you go here and update here, help, and here you can see the version of it, and here we have this integration runtime is already up to date. Now next thing we will see the diagnostics tools which is inbuilt by integration runtime. So you can see, you can open configuration manager, you can click on diagnostics here, and then you can see the diagnostic tool already present over here. Let me try to click on it and see how it will work. It is trying to check the OS configurations, collecting information about the node, checking the networking configuration and all the backend proxy, firewall kind of stuff. So it runs successfully, and now it has opened me a browser here, and in the browser you can see machine and OS configuration is success, node information success, download center network configuration is success, and the service network configuration is success. So that means our integration runtime does not have any issues right now. But if we do something configuration setting and something wrong happened over there, then it will create a problem. So in this, if we go here and change some settings, then it will affect our integration runtime, and we can see those effects over here when we run our diagnostic tools. Now we are seeing this logging, like how we can monitor our integration runtime, and for monitoring we can click on view logs. It will try to open our event viewer, and in the event viewer you will see these two new categories here under application and services log. One is the connector integration runtime, another one is the integration runtime itself, and over here you can see all the logs created by the integration runtime. Okay, we can do one thing here. Let me try to trigger our pipeline, and then we see that how this pipeline is logged, the information is logged over here. So let me try to trigger it. It is getting triggered. Okay, so it triggered. Now we will go on our event logs and check if those information is calculated here or not. So let me refresh it. So you can see the pipeline has run just now, and we have this activity ID over here. And if we see more, task controller completed calling thread task, this one, and some other information. Monitor, how you can check that this event viewer which we have seen, let me close this one, I have open two. So over here you see we have this activity ID 2BC3F. So we can copy this activity ID, and from this activity ID we get to know that this pipeline run happened from which ADF. So we will go here on our portal and we can see when I running this pipeline, this is the same activity ID we have. So 2BC3F and 2BC3F, this is the same activity ID, and we can compare it and we can check the logs from there. Now last but not least, we need to centralize the logging. So how we can centralize the logging of our integration runtime? For that we need to create a Log Analytics Workspace. So I have already created a Log Analytics Workspace here. Let me go here and going to the agents, and I need to install Log Analytics Workspace for my machine, and the agent needs to be registered. So I need to download this Windows N64. This is a MMA setup, which is Microsoft Monitoring Agent. Let me just double click. I'm just doing next, doing nothing else, and here connect the agent to Azure Analytics Workspace. And here it's require workspace ID and key ID of your Log Analytics Workspace. You can see in the back we have this workspace ID and the primary key ID. So I'm just copying this and pasting it here, and then copying this one and pasting it here. And it's a Azure commercial, it's not common, China, nothing, it's a commercial, normal. And one more thing, if we have a proxy setting, we can go in advance and set up the proxy URLs, but we don't have that, so I just cancel it. Next and next. So installation has been successful. Finish it, and now we will verify that our agent is connected to Azure Monitor. For that I need to open the monitoring. Inside control panel we need to find out the system and security, and here we can see we have this Microsoft Monitoring Agent. Let me open it, and if I click on Azure Log, you can see it is successfully connected over there. Okay, so this is how I have created an agent in Azure Analytics Workspace for my machine, and now my logs are getting sent over there. We have to do some more configurations for sending logs related to integration runtime. Okay, so now our agent is ready. We can see in the Log Analytics Workspace one Windows machine is connected, and now we can do the configuration for fetching or pulling those event logs from on-premises to here. And I already showed you that which events I want to send. There are two events. One is the connector integration runtime under application and services log, another one is the integration runtime. So let's define it over here. In these are the classic ones. I am just using the classic ones because those are easy to fetch those information, and add Windows event log. So here I am mentioning the first one. Remember, we should not make mistake while mentioning those names. This is the first one, and we need to add one more, which is integration runtime. The second one is this one. So these two I want to fetch information. I don't want any other things, or if you want you can have everything here, and we can hit apply. And now all logs related to connector integration runtime and integration runtime will be available in our Log Analytics workspace. Okay, so once you have registered the agent over here and you have set up the management and you are connecting this logs for connector integration runtime and integration runtime, now issue comes that when and how we will read the logs. We will click here on the logs button and let's close it, and here you can see we have two tables. One is a heartbeat. Heartbeat is related to integration runtime heartbeat information, and then we have one event. So let me try to run this event table and select everything whatever there, and here you can see we have all information about integration runtime whatever present on our event viewer over here. Remember that this information which is getting updated on integration runtime will take some time to getting updated over here. So first, if you run the event, you will not get all the details. It will slowly and gradually synchronize with your on-premises events, and then you will get all the information here. And if you want to open some information, like let me open this one, you can read what has happened. You can open another one and you can compare those events with the on-premises one. So this is how you can send centralized logging to Log Analytics Workspace from your integration runtime machine, and then you don't have to log into each machine and check the logs. You don't have to do that. You can check all the logs in the Log Analytics Workspace itself. In the last module, we have already learned about diagnostic tools, monitoring SHIR. In the demo, we have seen how to analyze as well as send logs to Logspace. Now this is our last but very interesting module, containerization of self-hosted IR. Sorry to say, but containerization of self-hosted integration runtime cannot be covered in this course. I will create a separate video and upload it in future. So you have completed this course, self-hosted integration runtime deep dive. I hope you have liked this course and appreciate the hard work of my team in preparing it. If you really like it, then appreciate it by liking this video and let me know in the comment section if you did not understand any topic. For more such videos, please hit the subscribe and bell icon. Thank you so much for taking this course. Wish you all the very best for a career as a data engineer.